I'm going to give you examples of bad analytics because that's basically where the field was to begin with. So first is the physician's verbal autopsy analysis. So what the heck is that? A verbal autopsy is not an actual autopsy. And in the United States, when somebody dies, there's a death certificate. And some doctor or medical personnel signs the death certificate and says the person died of stomach cancer or whatever it is. In most of the world, they just go off to the bush and they're never heard from again. That's it. Okay. There's no autopsy. It's culturally prohibited. Nobody sees the body. That's just sort of it. Yet those are the parts of the world that public health professionals need to know what people are dying from, so that they can direct public health dollars, so they can maybe send in the troops and do something about it. It's really like a big deal. That's what we need to know. So what do? You could do a verbal autopsy. You find a household where someone died, and you interview the next of kin, and you ask them a series of uncomfortable questions. Did the person who died have really bad stomach pain? Did the person who died have, look sort of yellow? Did the person who died have tire tracks across his back? To figure out the cause of death, right? That's not the actual question. So anyway, that's the method. The problem with the method, that's the method. Why is it a bad method? It's a bad method because what you would do is you would give the answers to the survey questions to a physician, and the physician would tell you what the person died of. That's a good idea. But the problem is what some smart aleck realized is if you give it to another physician, the other physician gives you a different cause of death. And the third physician, they give another cause of death. Basically, the physicians were useless. And if we get a really good physician from like Michigan, right, and we send them out there, well, won't that be better? No, it will be worse. Why worse? It'll be worse because when they see sniffles, they don't think malaria. Zero people have died in Michigan in the last several years from malaria. So they'll think have all the wrong priors, right? So if you can't do it with physicians, it's completely useless. They can only switch topics. Sentiment analysis by word counts. Okay, you've seen this in the media. Okay, people want to know. Well, I'll give you an example. You basically want. I'll give you an example. I was in Singapore recently. And in Singapore, the government was interested in what the people were interested in. They wanted to know what the people were focused on. What areas of public policy should the government focus on? They're sort of very focused on their people. Okay. So one of the areas was education. And so they took all the words that meant education classes, textbooks, right, schools, all of these words. And then they counted the number of tweets that used those words. Sounds like a perfectly reasonable method. And while they were doing this, they noticed a big spike in activity in education. And by the way, they were also watching the Olympics. And they were thrilled that they're distracted from their task, of course. They were thrilled that for the first time, someone from Singapore won a gold medal. Joseph Schooling won a gold medal in the Olympics. And Joseph's last name, right? Right? And there's actually a lot of examples like that, where in both of these methods work a little bit. If you apply them a little bit, they work, and a little bit more, they work, and then there's a catastrophic failure. That's the kind of thing that happens. It's quite unlike heart surgery, let's say, where nobody does just a little bit of heart surgery, like you're feeling a little like uneasy during dinner, you pass the steak knife to try to fix it a little bit, right? This is the kind of thing where you can really get into trouble because you can't do a little bit of it, but you can't do it at scale. You do sentiment analysis by word count at scale, and there'll be a catastrophic failure like that. These are unrelated substantive problems, but it turned out, after millions of tries, to have the same analytical solution. And here's what we realized. The key to both methods was classifying. We classify deaths into causes of death: malaria, tuberculosis, cancer, etc. And we classify social media posts into categories: positive and negative sentiment, the reasons why we hate each of the political candidates. There may even be a category for why we like the political candidates. So that's the key. Classifying, however, does not work very well. Moreover, we actually don't care about classification. We care about estimating the percentages and the categories. Let me make this clear. In public health, they don't care about you. They only care about everybody. Similarly, in In Twitter, no one cares what StatPumpkin222 says on Twitter, right? We only care what everybody says on Twitter. So that's interesting. We only care about the percent in the category. If you're not feeling well, go to your doctor, not the public health professional who's interested in the percent of people who die from malaria, right? So what was happening was the computer scientists and others were focused on increasing the percent correctly classified, which is absolutely right if you get to 100%. Because then the percent in the category is you just read it off. But if the percent correctly classified is not 100%, then you're making mistakes. And the mistakes could all be in one category. The best classifier with 5 or 6 or 10 categories might be 60% accurate, which would be terrific, or 70% accurate. That'd be terrific. You write the paper about that. But if you're 70% accurate, you're 30% inaccurate, obviously, right? That 30% inaccurate could be in category 1. What's category 1? Category 1 is the percentage of people who die from malaria, which you estimated to be 10%, but is that, or 2%, which is maybe trivial. Not if you have it, of course, but so maybe it's 2%, but the actual answer is 2% plus 30%, so it's 32%. 1 out of 3 people are dying from malaria, and that's a big deal, right? So all of a sudden, something that's really good in one domain, percent correctly classified being 70%, the Google search engine is not that good, okay, is a disaster for social science research. What we care about is the percentage in the category. This seems like a subtle difference, okay? But what we did is we developed a new method not to optimize the percent correctly classified, but to optimize the percent in the category. Because that's what social scientists care about. And that turned out to be a different kind of method, right? Let me say that again. So your spam detector. Oh, actually, I'll do it a different way. So there's about 1 million pairs of country years since World War II. US, Canada, US, Britain, right? And of those 1 million country year pairs, 1,000 were at war. Okay? So here's a really good classifier. No war. There's no war. There's never been any war ever. Okay? I'm more than 99% accurate. It's pretty good, right? Completely useless. Okay? So that's the thing, right? We only care in social science in many instances in the percent in the category. So we developed a method that optimized what we cared about rather than this other thing. The new method, by the way, we developed this in the verbal autopsy case, which was, we worked on it. It took a long time, but we got it going. At the same time, I was working on trying to do this project of understanding what political activists were saying from social media posts. And for a year, we were trying to develop these methods, and we tried every method in the natural language processing literature, and they were a disaster. They were just not coming anywhere near close. Until finally, like a year later, I walk in to my graduate students and I'd say, oh, I have a new method. I think this is going to work. And they're like rolling their eyes at me, but finally I said, wait a second, this other problem is mathematically identical to the first problem. And it's going to work. And they're rolling their, but actually it does. So it's the same method, same code. Right? Not only the same math, but the same computer code. Okay. Anyway, the new method led to Crimson Hexagon, which is Harvard licensed and MSU licenses technology, like they patent it when they license it to startups. So they license our automated text technology to the startup Crimson Hexagon that I helped found. And I like this quote. Fast Company, which is a magazine, names Crimson Hexagon the number 7 on the list of the 10 most innovative companies on the web, which I list because my brother, who works at Microsoft, Microsoft was number 9 on that list. So I was very happy about that. This is ridiculous. This is a start. Microsoft is like a country. Okay. Anyway, and then also the same method, same code is used by the World Health Organization to estimate the distribution of the causes of death in countries around the world. So it was sort of a cool project that I got to participate in. Okay, so I'm going to switch topics to Social Security. When I was in graduate school, my advisor said, you're doing things in all these different areas. You're really scattered. And then I tried to convince him, no, there's a field of political science called political methodology. We're going to have this field, and this is going to really be the thing. And they'd say, you're really scattered. Now you're doing another thing that we don't know what it is. And finally, I realized I finally convinced them when one of them literally said to me, she said, wait a second, I get it. You're not scattered. you're a methodologist, you're narrow. And now I said, yes, that's right. So now I can do whatever I want. Okay, so here's U.S. Social Security Administration forecast. Social Security is the single largest government program. It lifted an entire generation out of poverty. If it went away, they would go back into poverty. It's extremely popular. The forecasts themselves, the forecasts of the solvency of the program, are used for Social Security and other government programs too. They're used for more than half of the United States budget. They are incredibly important. If retirees draw benefits longer than expected, the trust fund runs out of money, and our grandparents get retirement money, but when we retire, okay? So it's like a big deal, right? If all of a sudden there's a pill that everybody gets to live to 200, well, that's really great until we realize the trust fund's going to go insolvent, so nobody's going to get any money. So you had better be able to forecast mortality and the amount of money in the trust fund really well. So it turns out that the Social Security Administration haven't actually evaluated their forecasts. They're required by Congress to make the forecasts and have been for 85 years. And they haven't actually evaluated the forecasts in 85 years. And we sort of discovered this. And so we used, their methods are basically not really changed, mostly qualitative. At this time in history, these last 85 years, we've learned more about forecasting and data analytics than at any point in human history or any other species history, so far as we know. And so what did we learn? Well, we used the statistical method that involved one of these lines like this, because we had the truth and the estimate, and then we subtracted one from the other. That was our methodology. Okay. So, come on, that's really funny. I just wanted you to know that. The results is that the forecasts were unbiased. That is, sometimes too high, sometimes too low. You don't expect them to be exactly right until about the year 2000. Afterwards, they became systematically biased. They actually make a whole set of different forecasts, and sometimes, and they were all biased, and they were all biased in the same direction. All biased in the direction of making the system look healthier than it really is. Actually, things are much worse than it seems, in like a big way. Why is this? As a side point, we had to go and do qualitative research to really figure out what the heck was going on inside the government. So the actuaries, those are the people doing the forecasts, the actuaries are people who you really want to pay attention to. They understand data better than anybody, but that's not really the place that has the most innovative forecasting methods, right? So, but anyway, the Office of the Chief Actuary does the forecast. They hunkered down, insulated themselves from the more political situation with both Democrats and Republicans preferring forecasts to be in one direction or another so that they can influence the policy debate. And they hunkered down and did exactly what we would want good civil servants to do, which is keep the partisans away. And while they did that, they also insulated themselves from the data. And while they were doing, so basically they were trying not to move because the partisans were pushing them and they didn't want to be pushed. And so when the data said, you should go in that direction, they went like this. And as it happened, since about the year 2000, Americans started living unexpectedly longer lives. Not only longer lives, but longer than they expected. If you take a statin, that's a good thing. Keep taking it. There's early cancer detection. Go to your doctor. Okay. And so it actually matters. So we developed some new analytics that not only reported these results, but in addition, we can forecast much better. No surprise, we're up against forecasting methods that were invented 85 years ago. Like we can do better. Okay. Using these better methods, we have some things that are perfectly obvious. Like unfortunately, older people have higher mortality rates than younger people, right? And that actually wasn't constrained to be true in the existing methods. There's a whole lot of things quite like that. We have far more accurate forecasts. The trust fund, we also found, needs about $800 billion more than the Social Security Administration. So we got to do a project like this, which was really fun and really cool. So, okay. And there's lots of other applications, of course, with the same methodology. Because the methodology, what is the methodology? The methodology is we have a time series of, let's say, 22-year-old women, and we have, and in the time series, we have the percent of women that die in each year, and we observe that for, let's say, 30 or 50 years. And we need to forecast it quite far into the future. So if we observe 50 years and we have to forecast 30 more, that's going to be very noisy. We're not going to really be able to do that. But if we have not only 22-year-olds, but we have another time series for 23-year-olds, and another time series for 24-year-olds, and also for men, and also for men in Kansas, and also for men in Wyoming, etc. All of a sudden there's a lot of data, but they're separate time series. And so we found a way to put a prior on the forecasted value so that there would be smoothness in the age profile, if any of you have done demography. So the age profile of mortality is you're born and things are sort of risky, and you get through the early couple of years, and your mortality rate is very low. And then your mortality rate starts to get higher and higher. And then you go through the stupid period, excuse me, but you're all in it. And there's a bump, right, because you drive too fast and all that stuff, okay? And then all that calms down, okay? But then, unfortunately, mortality keeps getting worse and worse. Okay? All right, let's switch to another thing. So the methodology put priors that demographers for years had known about in 350 years of demographic data from societies all over the world. This was incredibly valuable, essentially qualitative information extracted from quantitative data sets all over the world. And we figured out a way to take that knowledge and put it back into the model. And that led to these better forecasts. Okay. All right. We developed another technology we call it Pressure. And there's a startup called Pressure as well. And so here's the example. Any of you speak Chinese? Do you know what that means?
Freedom.
Yeah. So that's the word freedom in Chinese. And this is censored or actually filtered in many, but maybe 2/3 of the websites in China, social media websites in China. And if you use that word, they'll automatically filter it out. They may put it up later, but they'll filter it out. The Chinese people don't much like censorship, even though the government feels it's important, and maybe even some people in China think it's important. But in any event, if you write a social media post and it's censored, you don't really like that. So what do people do? What does that word mean? That word, you know that word? It means I field. It's not really a word, right? It's an I and a field, right? It's completely nonsensical. But you can see that, right, it looks very similar to the first one, to all but my friend here. It looks